Hello, it's Mr. Burkhart, and welcome to our recap for Wednesday, Thursday STEM physics lesson. We started with a Jamboard, which apparently I've already closed. So let me see if I can find that. Here's an example Jamboard. We did a Jamboard where we jammed. We also tried some breakout rooms. We had mixed success. Sometimes students talked to each other, sometimes they didn't. In today's Jamboard, we created some kudos for a friend, teacher, or parent. And you can see here's one from one of our classes. And then well, that's later on that same day. Let's see, what else did we do? Then I gave some lecture notes, apparently. So here's the lecture, a recap of the lecture. Basically, what I talked about was position, distance, and displacement. So we have a ladybug that's walking across the screen, and the ladybug is walking from point A to point B. And the ladybug, you can see that the ladybug has a long, winding journey to get from A to B. So to talk about the ladybug's position, the position is where the ladybug is at. Position is where you are at. So you could write that down. Position is where you are at relative to a starting point. You have to have a frame of reference, in other words. So relative to A, where's the ladybug at? That's the ladybug's position. And it changes over time as it wanders around the screen. The blue line represents the distance the ladybug travels. So the distance would be the running total of all of the mileage that the ladybug accumulates as the ladybug walks around. Displacement is the straight line distance from start to finish. So the displacement just basically talks about where your position is at, right? This ladybug could have had an infinite different number of journeys to get from A to B and have a whole bunch of different distances to travel to get from A to B. But at the end, the displacement will always be the same. It's just the straight line. Notice that the displacement has an arrow on it because displacement has direction. On this slide, I introduced the sheep here, and this sheep walks 6 kilometers, and then it walks 3 kilometers. So here we are. It walks 6 kilometers, and it walks 3 kilometers, and it walks 6 more kilometers. And the question posed was, what was the distance of the sheep and the displacement of the sheep? And right now, if you're watching this for the first time, I would like you to pause the video and try to figure those things out. In class, we did these on Jamboards and in breakout rooms. All right, thank you for pausing the video. If you figured it out correctly, you would see that the sheep walked 6 plus 3 plus 6, which is 15. So distance would be 15. The displacement of the sheep, though, is how far the sheep is from where they started, and that would be 3 south. It has to have a direction, right? It would be 3 south. All right, in the next slide, we have this scary-looking lemon, and this lemon walks 3, then it walks to -1, then it walks to -3. What's its distance? What's its displacement? So what we're going to do is pause the video and try to figure it out. I'll wait. All right, thank you for working on that. So the lemon started here and ended up here. So the distance is 1, 2, 3, 4, 5, 6, 7, 8, 9, right? The lemon walked 9 units. No, we didn't actually tell you what the units were for this problem. So whatever units you guessed are okay, but actually for this problem, we don't know the units. We would just say 9 units. The displacement is where the lemon is at from where they started. So that would be a magnitude of 3, a size of 3, right? It's 3 units away. We would say -3 because displacement has to have a direction. In this case, it would be positive or negative instead of north and south. All right, what else did we do today? So I talked about assignment number 2. I don't know why I'm here. Does anybody know why they're here? Really? All right. So actually, I went through and talked about a number of assignments. I talked about assignment 1 for the week in the measurement activity. What you're doing, what you're supposed to do is you've been assigned about 10 people to discuss this activity with for this one right here. And you're supposed to find some shoes in your house and write down the sizes of the shoes and then actually measure the sizes with a ruler, find out how many inches they are, and then try to figure out what the relationship is between the size of the shoe and the actual length of the shoe. Is there a relationship? And number 2, we talked about this, and basically, it's open right here. So basically, people's questions were, how do we make these drawings? So there's a couple of ways. Basically, oh, that's the wrong camera. Well, let me see if I can actually get this camera booted up here. All right, so that's upside down. So basically, what these motion diagrams are, if we have a person on a bicycle going at a constant speed, the model for that would be just dots, which are even distance apart. And if we had a car, say, that was slowing down, we would have dots, which were getting closer and closer and closer together. And if we had something that was speeding up, the dots would be getting farther and farther and farther apart. Sorry. All right, so that's all they're looking for, is just dots showing constant, slowing down, or speeding up. And so you can even just do these on paper if you want, like I did. And then you can just upload a picture into here if you want, or you can actually use the, you can insert a shape, such as a circle, like I did, and just make little circles here that show the dots either getting farther apart or closer together or staying the same. Right? And I hope that helps. And then we talked a little bit, that is not, I don't even want that open. We talked a little bit about, actually we were hoping to have a little bit of time to work on the gizmo together. I've made a separate video that explains how to get data for the gizmo. If you need that, please send me an email and I will shoot you a link. Also, hopefully pretty soon I will post that link actually on the gizmo assignment. Thank you.